Hello, my name is Tosh. I'm a composition major and music electronic minor here at UBC. I've been studying here for about 5 years, but just picked up music electronic about a year ago. I've been working on this capstone for about, give or take, 2 to 3 months. But before we get to that, I'd like to talk about what I will be doing after I am done here. Specifically, I will be wanting to work further on this capstone and try to develop it even more so that it can allow for more functionality. I'll also be wanting to further my commissions work and see if I can get some paying jobs working as a for-hire composer. My capstone is named DDR, Digital Distance Receiver. In short, it is a sensor board that allows a dancer to walk along the tiles and trigger various samples and effects. It can also sense how hard the dancer is stepping on said tiles and change various effects accordingly. In practice, it is 9 tiles that can react to you stepping and pressing on them during a performance setting. Many problems needed to be solved. How will it sense being stepped on, as well as the amount of pressure being applied to it? How will it connect all 9 tiles to each other so that all the data can be sent to one place? How will it be calibrated in an easy and understandable way? The first problem was solved early on, but required the most work. I used velostat as my main sensor, as it has a variable resistance when pressed upon. This variable resistance can then be calculated by putting a voltage through the velostat in a voltage divider. The voltage goes through the velostat, aka the variable resistor, and then divides off. One circuit going back to my Arduino near my computer, and the other going through a 220K resistor. This voltage divider setup allows me to calculate the variable voltage of the velostat, essentially providing data that mimics the sensor being stepped on. Next was expanding that to 9 tiles. First, I organized the sensors into pairs of 2, one for each tile. In total, I have 18 sensors across 9 tiles. I wired these sensors together for the use of old Ethernet cords. These cords have 8 wires inside of them, and since I had 6 sensors per set of 3 tiles, I could connect all 6 sensors to the Ethernet cord and use the remaining 2 wires as power lines, running up the left and right side of the tiles. This was then reproduced for all 3 sets of tiles. This Ethernet then runs into my Arduino, located inside a box that I will show you later. Inside the box, that has been modified to house it and the RJ45 jacks that Ethernet cords use. Finally, inside the box is the Arduino, which has a multiplexer soldered to it. This multiplexer reads the various wires of the Ethernet cord and sends them to A0 on the Arduino, allowing me to obtain all my data of each sensor simultaneously. I also had to use A4 and A5 on the Arduino, as the multiplexer could only handle up to 16 lines and I had 18 sensors. The final step was programming a calibration method so that the sensors reacted accordingly. This was done through MaxMSP and involves using the peak and trough objects. By calculating the difference between the two and dividing by 2, a reasonable detection threshold can be made. I then continued upon this by adding a reset values button to each of the sensors so that it could easily be calibrated and reset if needed. I organized my patch in a way that the panels were arranged to how they are in real life, thus allowing me to simply look at the patch and know which sensor specifically needed calibration. Now, I'm going to show you the actual physical capstone. This is one set of the 3 tiles. As you can see, the velostat sensors are taped down using duct tape and wired into this Ethernet cord. My power lines are brown and orange-white and run along the left and right of the velostat. My data lines are green, green-white, brown-white, blue, blue-white, and orange. For this, it goes into the Ethernet cord, up into this box that I modified. Inside the box, you can see the Arduino and the multiplexer, all wired up so that the data from the Ethernet cords runs into the multiplexer, into the Arduino, into my computer. This is my Max MSP patch. It is using a pre-made patch, Arduino 2 Max, made by the professors here at UBC. But my modifications are specifically in this encapsulated patch right here. As you can see from the interface, we have initializing buttons for each of the 3 tile sets, along with grand reset values, but we can also individually initialize each one. And they are organized in such a way that they correspond to their real-life counterparts. I also have a how-to in case one would like to use this and want to understand how it works. This button is just for turning on sound samples that allow, or sound samples that contain my voice saying out the numbers of each of the panels so that I know which ones I'm stepping on. This is what it looks like without presentation mode. You can see the raw data from the Arduino here. I will now perform a small demo of the Capstone. Thank you. I'd like to expand upon the functionality of this capstone by not completely remaking it, but learning from what I learned by making this and trying again. My original vision was I wanted something that could essentially be a touchpad for the ground, a sensor that could detect one person touching it with their foot and moving it across and being able to register that movement. This capstone is able to detect when someone steps on it, but it does not detect the movement between sensors. That is what I would love to eventually get to. I don't think this capstone can ever do that just because of the tools and materials I used, but the things I learned from this capstone, I could one day maybe make that. But to add to this capstone, I would want to add more programming to it, specifically more functionality in terms of separating sensors, turning on and off sensors, and seeing how I can work with that. Essentially making it more versatile and flexible so that I can modify it for any performance that I use it for in the future. This has been my video on my Capstone DDR. Thank you so much for watching, and thank you to the School of UBC, to Dr. Bob, to Daniel, the TA of 420, and thank you to all of the support that they have given me, and to everyone here. Thank you.